Yo, good morning, good morning. So we're gonna continue and polish the place system today. Let's see if we have it in a current state. Yes, we're experimenting with slurping between transforms to get rid of a lot of the flicker. Unfortunately, like the first idea we tried, so we calculate a end position and an end rotation, and then we slurp or lerp between those two. We're gonna have to change it up a bit because we get something like this. They don't work that good together, or the intermediate frames between the previous state and the current state. The rotation doesn't really work as I would like it to do. We always want the shovel to be pointed. It should never be more forward than the point we have. So instead what we're gonna try is that we're gonna calculate, or we're gonna lerp between points basically. So we're gonna calculate an end point at all times, and we're gonna have a current point, and then we're gonna lerp between those. So it's basically, we have a point with a normal, and then we have another point with a normal, and we're going to interpolate between those two, and hopefully that will fix the rotation. Still, we can see here that here we have it rotated with the thin side up. Here we have the big surface of the shovel up. So we're probably gonna need to do, we're gonna have to define, I wonder if we can fix this in some way. I guess we could define, instead of just using the normal, we can also use the tangent. And maybe we can make something. I mean, what we have now previously, or compared to what we had previously, this is like way better. But we still want to improve it even more, right? So this rotation here could be way nicer. Okay, so let's try that. So instead of updating end transform and current transform, we're gonna have update transform. Let's see. So we update endpoint, so anytime the focus point of the mouse pointer changes, we set a new endpoint here. And then we want to interpolate here. So I'm wondering if we're going to have endpoint and current point. I reckon change this one to update current point. And we're going to use current point on all of these. And I wonder, do we need set rotation? Don't update these here. Don't think we need to update these. So we're gonna have something like this. The only thing we need to do then is we need to calculate current point and replace it here. We need some way to check if current point... Oh, good morning, Cooler SK. So current point could be... we want to make sure that we set it to... So it could actually be unset. Previous to this. So the first time we do this, what do we want to set current point to? That is the question. And it's probably gonna be... We're probably gonna do something like this. If current point dot normal is equal to then we do current point is equal to end point. Else we do something else. Oops. Good morning, Harukanen. Cooler Sky, how is the implementation of the watering can going? We're not just there just yet. Okay, although I wonder, could we get... That's actually true, we could get something... something weird here. I'm kind of so cold outside this morning. Yeah, what the hell is going on? I actually had a jacket on while going to dropping off my kid at school. What the hell? I thought I thought summer had arrived, but I guess not. We also had a light drizzle outside, which wasn't pleasant at all. We can actually do if current point dot collider is equal to null. We have that here. No, that's endpoint actually. I think this will work. So then the key part of all of this is that we need to interpolate between current point and endpoint in a nice way. I'm wondering about... Rotate towards is pretty good actually. Rotate towards and move towards. We can try those. We're gonna get... Actually no. What we want to do is, let's try and paint this. We can start with move towards and rotate towards, but I'm gonna show why it won't work. If we have a point, I think this visualization was pretty good. So we have a point here with a normal in this direction, and we have a point here with normal in this direction. If we move the point, if we just take the point and move it towards, we're going to get a linear interpolation like this. So the point will actually be inside of this object. What we would like to get instead is a rotation like this. So I wonder if we would need to take the negative vertex, negative normal, find the intersection point, and that will pretty much be our pivot. And then we rotate around that point. That's one way to do it. Or actually, never mind. We're gonna do a sweep test. So even though... Oh, really? Yes. So we just interpolate the point. We don't need the normal. And then we do... Or do we want the normal? And then we do a sweep. Yeah, we want to... So we interpolate the point to get the position. So we're going to go along this object. That's going to be beautiful. And then we just rotate along it. Yeah, I think that's what we're going to do. So we just need to change the normal here. So I'm wondering if we can do... Current point. Oh, we're going to do it like that. Yeah, current point is equal to new point. Then we interpolate the position and the rotation with move towards. Do we actually have... Oh yeah, we have a 3 here. And... so we need to calculate the position here, and I'm wondering if we just want to do... vector 3 move towards... take current point, position, and then we take end point, end position, end point, position, something like this. And here we do rotate towards and want current target max magnitude delta. Don't we want this one to be 0? Yeah. So we just do rotate towards current point, normal, endpoint, normal, and max radians. Something like this, and then we do the sweep test and we reposition it based on the new point. Maybe. So here, instead of doing this, we do something like that. We can try it, see what we get. And actually, one more thing. Yeah, never mind. It was correct. So we have some delay in movement. Rotation, however. Did I screw something up? Rotation is pretty much instant. We can see we get some weird flicker here. I think it's because of this one. Let's go with 10. I don't know if we get some flickering, however. Yeah, we do. So the sweep test seems to get a little screwed up. But other than the flickering, I think this is what we want to do. Why do we get that flickering? I'm gonna do... let's lower these one to 1. And... like, if we get the flickering in slow motion... now, then it's because of us getting some bad interpolated normal values, which makes these sweep tests get screwed up. But if we don't, or if we get quick flickering still, yeah, what the this looks good. We still get some flickering. Okay. But quick flickering, that's good. Because then I think it's... it's probably the collider, actually. could it be? Yeah. So between this point and this one, we've changed colliders. And it hits this new collider here. Okay. This actually looks pretty good. So it's when we change collider. Yeah, because here we don't hit anything. Huh. Pretty cool though. So now when we change collider to this one, at the initial transformation, we don't hit any object. We don't hit this one anymore. Okay, how can we fix this? We have some wobbling going on here though. Wobbling here sucks, but there we have some very bad wobbling. Right at the edge. Maybe doing the sweep test. Every frame isn't the best. We have an easy fix for the collider. Because we do the sweep test on only this collider. We could do an additional raycast here. That's pretty much the two options we have, I think. Additional raycasts, or doing it mathematically by calculating pivot points and stuff like that. If we take this normal and this, maybe it's that easy. We take this normal, and then we do the cross product between those two. So then we get maybe something like this, and then we rotate this point around this one to this point. Rotate around, rotate around. I know, is that... Maybe. Then again, I prefer the sweep solution, because even though we do this, we might get intersections here which aren't gonna look that good. So even though we have an arc like this, that arc might be way outside of this surface, or it might actually be inside, and then we're gonna get some bad result. So doing sweep test continuously like this is probably the best solution. But If we're gonna do additional raycasts here, we would need camera. Like, it's pretty much, we need to figure out when to change this collider, basically. And yeah, it's the normal here that fucks it up for us. But then again, if we do this, if we don't interpolate the normal, we're gonna get some weird stuff. If we don't interpolate the normal, then we're gonna get instant change. So we have to find a middle ground where we want to use this, but we want to avoid flickering. Current point. And I don't see no other option as opposed to do I want to do it here? Yeah, maybe. But then again, if we do this, well, maybe. We want to release, we want to replace this with only one as well, I think. Yeah, we're gonna implement this one in a sec. I just want to hit game object here. Yeah, we're gonna do this. What's up, Hunter YouTuber? And Quiet, by the way. What's up, what's up? How much time has it been since you started working on this project? You should be able to deduce that from my devlogs, I think. But if I recall correctly, around 4 years, I think. Since the first time I put the pen to the paper, so to speak. But damn, I didn't know about this since I recently joined your channel. Welcome, welcome. Hope you enjoy. But I wish you good luck for your game, man. Thank you, appreciate it, appreciate it. Yeah, we're gonna grind it to the end, I think. Unless something very unforeseen happens. I wonder here if I still want to differentiate between these two. Now we actually call this one even though we don't get a hit game object. So let's just do point. Point. Then I wonder, pointer focus event. Three. Okay, we're gonna get rid of one of these. We're gonna do this one, I think. Wonder if we can do this. So now we have two of the same name, but we remove this one. Yeah, we force it like this. Actually, we're gonna do it like this. Highlight game object. Move placeable object. Yeah, then we'll remove this one. Beautiful. Let's see if we still have some. We can highlight objects, but we don't see any information. So what did I screw up? Action, interaction, focus, point. Yeah, okay, this time around we have this. Ouch. Mm-hmm. Okay, beautiful. So now let's jump back to input handler and we're gonna implement this one. Get intersection point from camera to position. Get intersection point. What kind of name is this? Get intersection point. Between camera and position. And then we basically want to take most of the logic we have here, I reckon. Yeah. So I'm talking about all of, not this one, but we're gonna take this. Gonna put it here. So what do we have? Do we have a vector 2 here? Deadmean Walking, what's up, what's up? How long have you been working on this? I just had a similar question a moment ago. I think I put the pen to the paper, started planning for the first time like 4 years ago, I reckon. Code at Dusk, what's up, what's up? Yeah, so screen point to Ray. What's up, Kuma? Pointer position value. Okay, so sometimes I want a 3D point in space. Right. Or we could transform this to... Could transform it to screen space and create a ray. How do I want to do this? If we don't hit anything, however, yeah, then probably this position. Or actually, what we're looking for here is it's just a difference in how we create the rays, I assume. We can probably take the camera position, yes. Does that make sense? I think so. But then I would like a get intersection point for ray. And that doesn't seem very input handler related. But we can do it. Get intersection point for ray. Yeah, let's do it like this. So then we just do ray and return point. So everything we need to do here is we just need to calculate a ray. Origin is main camera dot transform dot position, and the direction, I always forget here. Do we want to take hopefully we'll see. So we do it like this, and then down here we do this. Let's see what we get. Actually, I'm still wondering about... This is most likely the wrong direction, but we'll see. Okay, we can't double check it yet, but that's okay. And then we do action interaction place, interactable place. I hate that we check for input handler here though. That's fucking weird. But let's see if it works. So the idea is that we want to change this collider. So we do intermediate point is equal to we can fix this if this works. intermediate point, and then we do actually, I want to print this one as well. See if we shoot the ray in the wrong direction or the correct direction. Good start. We actually get it to null here, though. Maybe. Ah, that's probably because we're shooting it in the wrong direction, I would say. Let's try it. Yeah, we have the same issue as previous, so it's probably or most likely because of my inability to remember what direction we get when we do subtraction with points. Terrain patch, terrain patch, terrain patch. Why do we still get this weird offset though? This jump here bothers me. Maybe we don't want to do it from the camera, do we? This jump here is extremely weird. But this looks pretty good. That would look very good sped up, I think. That's pretty much exactly what we wanted. Holy fucking shit. So that's beautiful. Yeah, get over here. Yeah, sped up, this would be amazing. It's when we switch between objects we get... Oh, this looks so good. Or when we do... Okay, that doesn't look good at all. What's up with that flickering? Okay, we have a tiny bit of flickering. How good does this look? Like, this transition is beautiful. But this, what the fuck is this? I might know. Yeah, we do the sweep test. Yeah. We do the sweep test by taking the normal of the point. So here we have a normal pointing straight out from the object. And then when we switch, we have a normal that points roughly in the world up. But when we interpolate between those in the beginning, so when we get this jump here, we have a normal that points upwards, or yeah, we have a normal that points upwards, and we try to rotate it to the side. So when we do the sweep test, we get in from the side. Do we want to do the sweep test? Do we want to do the sweep test from the end position? We probably do. Let's see if we can fix it by going sweep test. We do it current point normal. We do end point normal here. Maybe. Maybe. What the fuck? Here it works. What? Now if we do end point, we do get some weird... We get some ugly... I'll try one more thing. It's not enough if we do endpoint here. We do... I don't know. Yeah, we get a little bit of a jump. But if we could get this one... It's too flickery. Having the current point here instead led to such a way more beautiful smooth animation, with some problems, of course. But in this case, I wonder how we would avoid the sudden jump, because what we're doing here is that we try and collide with the ground this time around. But this is so much better. Mm. This looks so much better. It almost looks like it's magnetic. Would love to see this in the correct speed later on. Hmm. what to do about that one. And this one as well. Ooh. Hmm. Yeah, here we're just checking against this collider, and that's why we get something like this. Huh. We force it to be here. Hmm. If we do a sweep test between this and this, we're always gonna get some jump at least. And that's pretty bad. because right about here we are intersecting with the object. Here we don't want to intersect with the object, or with the current implementation we disallow it. So even though we didn't get the jump in position, or this big jump in position, we would still be seeing some jump. Yo, what's up, Fabik? You have intersecting colliders cube terrain, that's why you shovel jumps between two objects. We know why it jumps, it's just that we want to implement a way for it to not jump. The current implementation allows for some very nice changes. Like this one. But yeah, this is what you get when you do sweep tests at every frame. So I'm pretty sure we want to avoid that. So now it's a question of how do we get this nice performance without doing sweep tests. And we're probably gonna have to do pivot point calculations and stuff like that. Oh, that's unfortunate. Fabik, I meant your cube is inside the terrain, that's why you don't get nice transition. Yeah, of course. But like, this is how I want it to be. I want to test transitions between two separate objects here from a edge case, pretty much. Okay, we definitely want to avoid sweep check when we interpolate between 2 points. But can we do this without? Maybe we can. I think Yeah, we probably don't want this intermediate reposition anyway. Was actually the previous solution the better one? If we just refine it a bit, that is. Wonder, we want to switch. Update current transform. Oh yeah, if we have this solution, we have to make this one a little bit bigger. Which makes me wonder if... Are we calculating the rotation in the wrong way? If we can make the... No. Okay. We want the point of the shovel to always be at the point. With this rotation, we get this little bit of a weird repositioning, temporary repositioning. The end result of the rotation is good, but the interpolation here is fucked up. Huh. How can we clean this one up? That's actually not too bad. The only reason this one isn't too bad is because the origin point here is pretty perfect for this use case. If we had a synced rotation and repositioning, it would be probably a bit nicer. One sec. Interactable place. Update current transform. Alignment rotation here. Yeah, we want to do this in a nicer way. I'm thinking that we want to do this alignment rotation every frame. That's our end rotation. So I'm thinking if we want to interpolate this normal, we interpolate this normal much like we do this, but then, yeah, I think we can remove. I don't care too much about these two right now. So I'm wondering if we're going to do endpoint here as well. And we interpolate this normal and do alignment rotation at all times. Are we going to see... Yeah, maybe. Yeah, let's do this. End position and rotation. Instead we do endpoint is equal to point. And then we do something similar to this one. Otherwise, move towards, rotate towards. And we do set position like this, but the rotation we set like this. Maybe. Okay, that's not good. Oh yeah, of course. Endpoint is equal to really? End position, yeah, of course. Set position, we should be move towards current point, or set position This should just be current point dot position. Move point, rotate normal, and then we set this one to current point position, but this one we recalculate based on this one. Okay, this has to be it. I hope. Okay, we get instant. We have some noise here. Why are we instant here? But the flickering is pretty... here we have flickering. Delta time, delta position max. Yeah, it should be extremely slow. Move towards... Are we getting this one? Yes. So every time we set current point, we set game object to null, which means that we set current point to end point instantly. Let's see. Yeah, okay, now we have... Okay. I mean, it's better. I don't know how I like... I guess it's gonna be hard to... It's way better. We still have some... If we could get... If we interpolate the position by an arc instead... and sync rotation and repositioning a little bit better. we don't have this problem anymore. It might just be a sync problem. If we can try and see how this looks with better synced between position and rotation, because right now we get the rotation done way before the repositioning. This rotation is pretty insane though. Rotate around. Yo, what's up, Gerald? Yeah, the repositioning happens extremely quick. What is that? So this looks pretty nice. With a perfect origin point. Like, even if we made this, let's say we make rotation 10 times faster, you're still gonna see this flickering when it rotates inwards, pretty much. We're gonna have to limit it to some point in some way. Because what we see here is we rotate around this point when we want to rotate around this point. So we need to store this in some way. But didn't we have Unity rotate around? Transform rotate around. Maybe that's okay. Let's see. Do we have transform rotate around? Do we have a static? No, we don't. Because we could use this one to calculate the quaternion, and then we set it on the rigid body instead. If we use this point and this, so the cross product between these two, how would it look? Then we get a cross product in that direction. And that's what we want to rotate around. Maybe. I guess we can try it. So point. But that would look. This one changes position as well, I reckon. If we had the shovel looking, then we rotate it around this one, around this point though. Would that bring us... Or do we want to rotate around this point? By this one, yes, maybe we do. So we always take current point, rotate around current point. Yes. Maybe. Let's try it. So we want to calculate current point, but then we don't want to do this. Instead, we want to do dynamic entity game object dot transform dot rotate around current point position, and we want the option where we have a axis, and the axis should be if we do current point normal, yeah, maybe. So we do vector3 dot cross between current point dot normal and endpoint dot norm endpoint dot normal, and then the angle in question we do time dot delta time times delta rotation max. Currently we don't move it. I want to see how much rotate around moves it. Then we need to do this as well. We actually have transform here. Okay, let's see what kind of movement we get here. I wonder... I wonder if we get any at all, actually. And we don't get any rotation. Not getting any position change, I can understand. But not... here we go. Hmm. Rotate around. Hmm. Yeah. These messes with those. Fuck, we're gonna have to do it like this. Like, we're pretty much just using the transformation as a temporary storage. Because we want to use the rigid body when we move this stuff around and rotate it. Come on. Wrong order. Or we can always solve this ourselves without relying on rotate around. This one is the best one yet. Except for the weird rotation, that is. Okay, so I wonder. But it is rotate around. Yo, what's up, TM? Do you already have ideas for type of creatures you put in the game? Are they more cute, cool, etc.? Yeah, I have some concept arts laying around. I want to go for some variation. I'm not gonna lie, most of the ones drawn so far are more cute than anything. But we're definitely gonna do some that aren't. I think we're gonna implement the first monster after this summer as well, so it shouldn't be too far away. Wait, do we have instant rotation? Yeah, of course. Yeah, I think it's gonna be very fun. We're gonna start with some very simple ones as well. So you gotta have blobs, right? Blob monsters. We're probably gonna start with those, or I also have an idea of a pretty static stone monster, which pretty much doesn't need to feed. It just lays around. Team, love watching you progress with development. Appreciate it. I love progressing with the development and having people watching it or following it around. Don't know if that statement is... yeah, everyone loves rocks. That's definitely true. And yeah, we're gonna start with some pet rocks. I'm thinking just a rock with a couple of eyes. That's about it. Can't move, can't eat, can't drink. It just lays around, feeling not happy, but content, I guess. So that will probably be the first creature we're gonna implement. Okay, how many eyes will it have? 5? Actually, that's a good idea. We might... So, I want to add like small variation between creatures. So with the stone creature, maybe it will have... Some of them will have 2 eyes, some of them will have 5. We'll see. But yeah, before we implement something fun like that, we need to get this rotation implemented. And I hate implementing rotations, but I'm not going to give up. The fuck do we have here? Inbreeding extra eyes. Maybe. I don't know if we're gonna keep... Yeah, we're gonna... Maybe we'll keep track of lineage. Lineage. And add a inbreeding parameter. We'll see. Is it just about adding an offset actually? Maybe it is. if we add a current offset, we have the point here, we have the origin, we calculate the offset, and then we just keep that offset while rotating. Could it be? But we'll see how this looks with some slower rotation. We're gonna go 1. Point is here, but the interpolation point is not here. So we want to take we have the point somewhere around here. We take it minus this one. We can see that it's shorter than it should be. So then we just move this object, the missing part, upward. Maybe. Maybe. Yeah, maybe. We need to save something here. Private float. Let's just put it as offset. And then we do... So this is where we calculate endpoint, and then we calculate offset is equal to... Yeah. Offset is equal to... yeah, let's do point dot position minus endpoint dot position. That's our offset. And then we set the position here and we calculate we do the rotation first, and we do the position, and then we take can we do it like this? Let's just call it O. What did we do up here? We did point, position, end position. Position. Dynamic entity get position. That should be current point position though. No. We want to do current point dot position. Oh, fuck, how do we want to do this? Point position, endpoint position, yeah. Then we get the offset. What do we want to compare it to down here? Current point. We want to do it like this. Let's see what we get. So many things can be wrong currently with this. Okay, we do it in the wrong direction, but it still doesn't look. It still doesn't look entirely correct. Oops. And we get it like this. Yeah, we don't want to add it. Oh, that's true. could it be? No, it still doesn't rotate nearly the way I want it to rotate. Rotate around point is definitely what we want. But. But doesn't that make sense? So we take the origin into account. We have the point, we place it at here. So this is the point, here is the origin. This is the offset we want to keep at all times. So when we start rotating, so here, for instance, the point is here, the distance to origin is so we take the point minus origin, and it's way less than the original one. We subtract those two, we get this distance, and that's what we offset this point with. That should be how it is mathematically. I just need to implement it. And this point is the point we have marked. And we want to get an array, or a vector, I mean, from this one to this one. So what is it? This one minus this one, right? This one minus this one. So origin minus point. Which makes me want to do this. But yeah. So this is the offset we have. So is it about endpoint? Okay, if we always want to keep this offset, do we want to have point dot position here? Current point position, endpoint position. So now we have it without offset. Now we just set the object to be this position, and then we want to do plus offset. Right. But never mind. We probably want to make this... If we just do this distance... Offset distance... magnitude, and then we do offset distance times current point dot normal. Maybe. Fucking origin points. We don't have this offset here. But... Holy fuck, does this rotation look good? Okay, so if we just get the offset correctly calculated, then maybe, just maybe, we got this. Why are we just getting half though? That's weird. Entity set position, current point position, plus offset distance times current point normal. Offset distance magnitude. Point position. Ah, of course. Let's try this. Mm. Really? Must have screwed something up. One should be normalized, shouldn't it? Or that's pretty much the assumption I've been doing this on. Get the fuck out. But then again... we move position way quicker. Then rotation. The position. No, I don't buy it. I'm doing something wrong. Get a little bit of an instant jump here as well. What's that about? Only from this to this though, not from this. This one eventually ends up being correct. This one eventually ends up being correct. Current point position. Current point normal. Point position minus dynamic entity get position. Hmm. This one eventually becomes correct, but during interpolation, what am I missing? I would take current point normal. Current point normal, end point normal. Alignment rotation is according to the normal and the default rotation, which haven't changed here. But yeah. Hit distance. We hit this point. This is the origin. This is our offset. And while we interpolate to a new, we hit this point. Here is our origin. We don't hit any point anymore. That is true. What do we compare with? Now we have calculated the offset and we do current point position, which is somewhere around here. We go from here to here. So we place this shovel here and then we should offset it to the current normal. This should be... never mind. The normal is... point, interpolate position. We place the shovel here and offset it by normal. What am I missing? This should work, I reckon. But mm, could it be that our initial endpoint okay. Nah, that shouldn't be it. Could it be? Yeah. Set rotation. We set the rotation to the hit point, right? Yeah, we do. Point normal. Rotate and reposition, and then we do a sweep test. So we do the sweep test as if the shovel or object in question was already rotated to its final rotation. Which means whatever endpoint we get here should be correct at all times. This is the end result we get. This offset is beautiful. Magnitude is beautiful. But this is not. Current point normal, yes. Alignment rotation, yes. No, it's something with... The only thing I can see wrong here is that the sweep test we do gives us the wrong endpoint. But if it eventually gives us the correct endpoint. The initial jump definitely... it's not a... Yeah, it's an initial jump. Is it only... It's not only rotation based. No, it isn't. We actually changed the position for an instant. The rotation is good, the instant position jump. It's is it because of this one? Current point game object is... No. So the initial jump, where do we get that one? Why do we get that one? Current point position, end point position. Current point. So the initial placement, definitely we get a jump, but that one I'm okay with. The second jump, or the following jumps, rather. Current position. Yes, could it be? So if we are in the process of interpolating, this one returns the non-offsetted position, yes. Previously, no, this returns the offsetted position. Previously it didn't. Get position. We have an implementation previously where this one was set to including the offset. Yeah, I think so. So now when we always add the offset here, does this affect point position plus point normal times 10? No, it doesn't affect this. This one should be... In fact, we want to add offset here, don't we? We want to add offset here, don't we? No, we add offset here. But here we don't. But that's okay. Yeah, the initial current point is wrong. The initial current point is without the offset. Current point position move towards current point, we set it here. Current point. Current point. So the first time around we set it to end point. Get the fuck out. First time around. We just set it to end point. Point position. Yes. Could it? Nah. Nah, this is correct. But it's related to the current transformation. Yes. Because if we jump, if we already have a good rotation, then it's good. Is it based on rotation? So here we switch 90-degree switch, and that's when we get the jump in position. But on the way back, we don't. We do the sweep test with the correct rotation. Roman X, so what's up, what's up? I wish I knew enough to be of any assistance, but sadly I'm on day 3 and still haven't entirely figured out the new input system. The new input system is quite complicated though, I would say, but it's extremely powerful. I wonder if I don't know where the error is actually. We update this every frame. Just need to double check. Action interaction place. Update end transform, update current transform. Yes. Romanex, yeah, the documentation for it wasn't good. Every YouTube video I've watched does it a different way. Yeah. I even have a YouTube video up on it, I think, the new input system. Don't know how much detail I go into it though. It's been a while. I would say I thought the documentation was pretty good, but it was, I don't know if bloated is the correct word, but there is definitely a lot of information. The documentation even does it in multiple different ways, I think. Could it be? Could it be? No. The document I found on Unity's website was less than half a page of obscure and irrelevant info. Maybe I need to search more. I think... I remember it as pretty... Can't we even go to Unit 6 here? Maybe not. Is this the new input system? Yeah, it is. It's pretty hefty, to say the least. But this offset here, I'm pretty sure we calculated it in the wrong way. Oh, no problem at all. And good luck. It has to be this offset. Let's debug some shit. Offset a distance. Let's just see how this value transforms during the placement. And thank you for the follow, appreciate it. Let's see how this value changes during the placement. So here it's the same. Oh, you see. That's not the... that's not what we want to see. So it grows for each change in point. This one doesn't. This is the same every time. So that means that this one changes. Why though? Hit distance. This should be the distance between the current position and the hit point. Do I need to do some drawing here? Maybe. So what we do is we take the object, or we have a point here. We take the object and set the position of the object to be equal to that position, that point, and it has a normal as well. So we move it 10 units away, so maybe we end up here. Then we do a sweep test in the opposite direction of this normal, so in this direction. And whatever result we get, we set the position of this one to the hit distance. So its current position, which is this, minus this normal in this direction, multiplied by the hit distance. And we have a collider here, so the hit distance should be this. So we take this position minus this one, which means that we should get our object here, right? Hit point, and then we take the offset is equal to point position minus, so this position minus this one, and that's our offset. So now my question is, why does this one change? I'm assuming we get a hit every time, so we never do this. And then we set it to current position. I don't get it. I don't get it. This one has a final say in what position we place it at. So it has to be... It has to be this one. Is it that we don't take into account the offset here? That's what I'm wondering. Um, the distance from the ray's origin to the impact point, yes. Okay. Sweep test. So I guess the origin in this case is the object's origin. So position. But that's the only issue I can see. And then it gets more and more and more offsetted. Yes, okay. Wonder. The length of the sweep. Maybe we want to... all points contained in any of rigid bodies colliders. Okay, so it's probably not this one then. Maybe. Could it be that we have it positioned by an offset first, which means that when we do this, this is including the offset, or not this one, but I thought we set it to this current position. We only use it here, get position, and then we just replace it. So whatever position we have at the end of this one, we don't bring it over here. Okay. And we get an offset of 0 initially. And look at this. If we change halfway through, we don't have this problem. Hmm. What am I missing between these two calculations here? What is it I'm not taking into account? This one. This one, what am I missing here? If we can't use this one, point position, dynamic entity get position. Is it some late update? Don't think so. Huh. I assume that this one is normalized. It should be. I think. When we change point alignment rotation, will change quite a lot. We align it with it should be okay. I want to see if this one changes. Hit distance. Yeah, we move it out more and more, do we? Let's see, start placing. 8.9. Yeah, it does. that shouldn't be the case, okay. Dynamic entity. Is it because of rotation? Point normal, no. Okay, so during the iterations, we just store some values here. We reset to these later on, so I'm gonna ignore those. Alignment rotation, default. This one doesn't change between frames. Point normal, this one doesn't change between frames, so none of this changes between frames. Then we just set this rotation, and then we set the position. Point position, this one doesn't change, this one doesn't change. And since we set both rotation and position, I have assumed that this, when we do the sweep test, it's this rotation and this position. Point collider doesn't change. So why the hell does this one change? Gerald got all my animations playing nicely in Unity finally. Nice, nice, nice. So what turned out to be the problem? We set rotation and we set position. This makes no sense. It's some information I'm missing. So set rotation, set position on dynamic entity. We do set them by, we do RB move rotation. Could it be, here we do RB position. Could it be rigid body? Probably yes. Do we have... If this has been the problem... Fucking hell. Gerald, the scale, transforms, and some export settings. Yeah. Nice that you solved it. That is not the problems that exporting from one software to another can lead to. Huh. Okay, I'm pretty lucky I found that issue. Okay, this looks very nice. Now if we can just... We need to time the rotation and the repositioning better. Yeah, we're still gonna see when we do it like this. If we do it quick, maybe. So the quicker we do it, the less... clipping we will get. Jesus. This is looking real nice. I still hate this problem we get though. That we can place... Ah. Okay, beautiful. We can work with that. And this one is probably because of this. This jump right here, however, okay, so it's not perfect. But we're getting there. So the rotation and position should be synced for sure. I still wonder about this one. Where do we get this? Yeah, we get an offset change. We need to... Yeah, we need to interpolate the offset as well. I'm pretty sure. That's okay. That is okay. Okay. So. We want to sync this one and this one. So move towards should be t-based, and we can calculate the t from the position, I think. Or no. Sometimes we want the position to rely on rotation, and sometimes we want the rotation to rely on position. So we're going to have to calculate which one of these are the biggest. So the change here, bringing us from current point to end point, is the position change the biggest, or is the rotation change the biggest? I need to think about this one. So yeah, this one is gonna have to be very dynamic. So for instance, if we go from this one to this one, we want it to happen quick. The position needs to be extremely quick, I think. But it's hard. So if we have this one here and we put it over here, we want it to happen pretty quickly. But if we base the speed on that assumption, then going from here to here, maybe it's okay. Maybe I just want to see what happens if we have delta position max 10 meters per second. We have some flickering here. I don't want, if we do position instant, we might get something weird. Actually, position, we might want to have position instant and only interpolate rotation. You might be correct. We want the rotation to interpolate because we want to avoid flickering when we switch between these two, right? You're entirely correct. Positioning we might want positioning instant. Yeah. We can take 1,000. Yeah, we definitely want position instant. I wonder, do we have some flickering? Yeah, positioning we want instant. Or how weird would it look? Nah, position we want instant. I wonder about... Yeah, this one we're gonna have to fix as well. So finally we want to do move position so we can skip the flickering while we move around, I think. Yeah, Gerald, the table shouldn't even go sideways. It should just jump from the ground to the top of that cube. But what if we want to place it like this? I think we can have a quick rotation here. Definitely want it quicker though. We do 10 times faster. I'm a little bit afraid of flickering. Like, flickering is what I want to avoid here. Oh fuck, this is beautiful. This is beautiful. You'd never place a table sideways on a wall. I know people who places rugs sideways on the wall. Maybe not a table, but it could be some other object. We're gonna get into more object-specific setups soon. Oh, this looks absolutely beautiful. Absolutely beautiful. This, I don't know how we're gonna do this. Depends on what we decide to do. If we're just gonna have the outline here or not, but holy shit. But I do 100% agree. I don't know anybody who would place a stool like this. It's all for free creative expression. Yeah, that's true. But yeah, that creative expression gets destroyed right about when we drop it. Yeah, we need to fix the drop animation as well. Yeah, this one we need to fix as well. So when we drop it, okay. Yeah, I see. But this, absolutely beautiful. Absolutely beautiful. Ah, here we have some flickering. Yeah, we're gonna have to base it on... It's a bit too much, honestly. But here it's almost too slow. And here it's a bit too much. So yeah, we're gonna have to base it on a few different parameters. But I don't know. This annoys me as well, but we're gonna get into that. Okay, this is pretty damn nice. But we're gonna have to take, so we have this one rotated with the backside upwards here, and here we have it on the side, and definitely want this rotation to transfer over here. So but we can check into that soon. And then we need to fix this as well. There's still a few things left. Do I love this? So then if we can start placing this one, then we add some custom rotation. So we rotate it so it's leaned back a bit, and then we can place it leaning against this one and stuff like that. I think it's gonna turn out real nice eventually. Can we pick this one up? No. Okay, we're gonna have to continue polishing this placement system tomorrow because I need to run. But fuck, am I happy that we solved this issue. I think this looks beautiful. Yeah, so if you run around with the shovel, you will pretty much have the option of just dropping it where it is, or you can lean it against the wall eventually. Will be nice. Thank you, Gerald. Appreciate it. And thank you so much, everybody, for watching. Appreciate that as well. Hopefully I will see you tomorrow. Thank you, TM. Appreciate it. You too. Have a great rest of the day, everybody. Peace.